Welcome to the topic of definite integrals in calculus. Let's delve into the world of definite integrals to understand their significance. A definite integral represents the signed area under a curve within a specific interval. It quantifies the accumulated value of the function within the defined bounds. Unlike a definite integral, an indefinite integral lacks specific bounds. It yields a set of functions along with a constant of integration, providing a broader range of possibilities. Moving on to the core concept, the definite integral calculates the net area between the curve and the x-axis over a defined interval. This evaluation considers the curve's position relative to the x-axis, determining the positive and negative areas accordingly. Diving deeper into applications, definite integrals are instrumental in determining the total accumulation of a quantity over a specified interval. An illustration of this concept involves calculating the total distance traveled based on a given velocity function, showcasing the practical nature of definite integrals. Transitioning to theory, the Fundamental Theorem of Calculus establishes a profound connection between differentiation and integration. It serves as a fundamental pillar in understanding the relationship between these key calculus concepts. Practicality shines through when knowing how to evaluate definite integrals, empowering the resolution of real-world challenges involving rates of change and accumulation. These problem-solving capabilities extend across diverse fields like economics, physics, and engineering, demonstrating the broad applicability of definite integrals. In summary, a definite integral encapsulates the signed area under a curve, aids in determining the net area with respect to the x-axis, proves crucial in accumulation scenarios, and establishes a crucial link to differentiation through the fundamental theorem of calculus. Now let's engage in an interactive quiz to solidify our comprehension. 1. Why is a definite integral essential in calculus?